Lesson 4, hauling, loading 2. We continue with chapter 4, and we have 3 learning objectives. Explain the operation and operational management of loaders, strippers, trucks, and other hauling equipment. Determine the number of units required for haul units, and also estimate production of loaders, stripper, trucks, and wagons. The first equipment we continue for this lesson, it will be loaders, and the finger on the right, see what is the loader about. So what is the purpose for the loader? The first is used to excavating the soft to medium hard material. Excavating soft to medium hard material. So not used for the hard material. Sand should be good, not stub, clay, etc. And it can also use for loading and hauling. And also used for stockpiling and backfilling stock. Piling and backfilling. Backfilling meaning that when you finish excavation, backfill the material. And of course, they can use for other purposes such as the tool carrier or material handler. So that's the purpose for the loaders. In terms of the productions, in terms of the loader production, of course the equation still the same that what we do in dozer in lesson 3. So it will be equal to the volume per cycle, and you can see volume per cycle, time, cycle per hour, and then time efficiency factor. So that apply for dozer, loader, scraper that we learn next. So how, and to determine the cycle per hours, we need to determine the cycle times. How can we determine the cycle time? We have a few notes here. The first one, the basic cycle time. So that will be in table 4.6. And for the travel time, typical travel time, typical travel time, we can that in figure 4.16. And then for the travel time, if the distance less than 80 feet, then you only need to use the basic cycle time in table 4.6. So if we have the travel time, consider 0 if distance it will be small for the travel time if the distance is less than 80 feet. So we only need to use the basic cycle time in table 4.6. So only use basic cycle time, which is table 4.6 as mentioned earlier. So before we go to problem 1, let show you for the loader. This is table 4.6 and the basic loader cycle time. And as you can see, it depends on 2 things: the loading condition, what type of material, loose, average, or hard materials, and what type of the loader is, articulated wheel loader or track loader. The one you see in the figure here, it will be articulated wheel loader, not track loader. And with that, the travel time for the loader, we can, if it is more than 80 feet, so you can use the travel time, and in this case, it includes both whole and return, so keep that in mind. Can be used for this finger, but for the distance here, one way whole distance, so you have to find out the travel time for each way and then add them up. So with that one, we can go to apply for the problem 1 here. Estimate the hourly production in a loose volume. So the keyword again, that loose material, with the 3.5 cubic yard wheel loader, loose material sand in a pit and move it to a stockpile. The average haul distance, so you see the distance we have, and it's more than 80 feet, so we need to find out the travel time. And effective grade, 2%. The bucket fill factor, this is go back to lesson 2, 95%, and the job efficiency, 50 minutes per hour. So how can we do this one? As you can see, the equation is volume per cycle times cycle per hours times efficiency factor. We already know efficiency factor in this case, 50 minutes per hour. Then we need to find out volume per cycle and cycles per hours. So first, the volume per cycle, how can we determine? In this case, for one loader, it's 3.5 cubic yard, and in this case, you have that cubic yard, and the bucket fill factor 0.95. So you time that one to account for the bucket fill is not always compacted in there. This two we have that is 3.325, and it become a loose cubic yard disturbed per cycle. So we have that per cycle. And now we need to find out the cycles, number of cycles per hours. To find out number of cycles per hours, we need to find out the total cycle time. And total cycle time, it including basic cycle time, table 4.6, typical travel time, and that the two we need to find out. So let first, basic cycle time. Basic cycle time, and we go to table 4.6, and in this case, loose material and wheel loader, loose material. So go back here, loose material, wheel loader. So we have the basic cycle time is 0.35 minutes. 0.35 minutes. So up here, 0.35 minutes. And then we have travel time. We need to find out travel time. Travel time, you finger 416. So because is the time if whole distance is 300 feet. 300 feet, so we can more than 80 feet, so you have to use the travel time in the figure 416 to determine. Let's go to here. So for travel time here we can have 3, and you see the effective rate 2%. So effective rate 2%. Go down there and go here. So E is about 0.35, 35 minutes again. So we can go back there. It also 0.35 minutes from what we learned. So from that we can have the total cycle time. By add those two, it equal to 0.37 plus 0.35 plus 0.35. We have 0.7 minutes. And when you have that 0.13 minutes, you can have the cycle per hours. Then we can have cycle per hours, number of cycle per hours. So it equal to equal to 60 minutes per hours divided by 0.7 minutes, that unit conversion. So you will have that equal to how many cycles? 60 divided by 0.7. So you get that is about 86 cycles per hour. So from that we can have productions general equation equal to the volume per cycle 3.325 time number cycle 86 time efficiency factor 50 minutes per hour, so 60, and from that one we have 237.5 loose cubic yard per hour. So that it will be productions for this loaded.